Okay, now we're going to do balancing reactions, okay? Balancing reactions has to do with the law of conservation of mass, meaning we can't have mass created or destroyed or matter created or destroyed, all right? So let's look over here. When we write up a skeleton equation, which I said you guys are going to be the most familiar with, this is where you just write the formulas of everything involved. Anything on the left-hand side of the arrow is called the reactants, or called the reactants. Anything on the right-hand side are called the products. That's just a vocabulary we use. In this arrow, it's important to understand, is not an equal sign, all right? 3 plus 4 equals 5 plus 2. They're the same thing. But here, acetylene and oxygen are not the same as carbon dioxide and water. They're very different. Here's our word equation that I talked about in the last video. Acetylene gas reacts with the oxygen gas to produce carbon dioxide and water gas, right? All the reactants and products are gaseous in nature, no big deal, but this is us describing what's happening. So now let's get down to balancing the equation, all right? We have to make sure there's the same number of elements on the left as there are on the right, okay? So if we look here, we have 2 carbons on the left here in acetylene, and over here we only have 1. But we can't just add a carbon. Carbon's tied up as carbon dioxide. When acetylene burns, it does not make carbon, it makes carbon dioxide. So we need 2 of those carbon dioxides. Great. 2 hydrogens, very easy. Now if we look at oxygen, there's 2 oxygens here. 2 times 2 is 4, so we have 4 O's here, and 1 O over here, so that's 5, all right? Well, 2 times what is going to give us 5? All right? And I'm going to be using fractions. 5 halves times 2 gives us 5. We have the same number of oxygens on both sides. But there's a catch here. We always want to use whole numbers. So what am I going to multiply this by in order to get a whole number? And multiply it by 2. If I multiply this by 2, I get 5, which means I have to multiply this by 2. I need to multiply this by 2 and this by 2. And the last step all the time is to check to make sure you have equal numbers of all your elements. 4 carbons, 4 hydrogens, 10 oxygens, 2 times 4 is 8, plus 2 is 10. It's a balanced reaction. I'm going to go through and do these 4 as well, all right? So let's start up here. Methane gas burns with oxygen, all right? This is what's going on when you turn on your furnace or when we light up the Bunsen burners. We have 1 carbon here, we have 1 carbon here. We have 4 hydrogens here, but only 2 hydrogens over here, which means we need 2 waters in order to make sure that we have 4 hydrogens on the right. Here we have 2 oxygens, 2 oxygens and carbon dioxide, 2 from the 2 waters, so we have a grand total of 4 O's. We need a 2 here. We're done. We balance the reaction of methane burning and oxygen. Here, sodium hydroxide in the aqueous phase is going to react with copper 2 sulfate in the copper 2 sulfate in the aqueous phase to give us solid copper 2 hydroxide and aqueous sodium sulfate. So here, 1 sodium over here, 2 sodiums over here. I need a 2. All right? Now, hydroxide we can view as one thing because the OH doesn't break apart. I have 2 hydroxides over here. I have 2 hydroxides over here. Great. 1 copper, 1 sulfate, 1 sulfate. This is a balanced reaction. Here, phosphoric acid or aqueous phosphoric acid reacting with solid magnesium hydroxide. All right? So we have 3 hydrogens here. All right? This one's going to be a little strange. All right? When we do this one, I'm actually going to change how we look at water. It's a hydrogen adding on to a hydroxide. So here we have 3 hydrogens, all right? Here we have 1 hydrogen, so I need a 3 here. Here we have 1 phosphate. Here we have 2 phosphates, so I need to change this to a 2, which immediately changes my hydrogens before. I need 6 here. 1 magnesium, 3 magnesiums, so put a 3 here. So in magnesium hydroxide, you have 2 hydroxides. But if I have 3 magnesium hydroxides, that means I have a grand total of 6 of them. And if we go over here, I have 6 hydroxide ions. Everything is balanced. We've now balanced this reaction. Lastly, ammonium dichromate, When you heat it up, it'll decompose into these compounds. So this one's going to be a little bit harder to do, but not much. I have 2 nitrogen atoms here, all right? I have 2 nitrogens over here, great. I have 8 hydrogens here because I have 2 ammoniums. I only have 2 hydrogens here, which means this needs a 4, right? I have 2 chromiums, 2 chromiums, 7 oxygens. I have 4 oxygens here, and 3 here gives us 7. This is a balanced equation. We're going to be doing a lot of these for practice, but here's 4 that you can refer to if you're having any difficulty.